UML, that is Unified Modeling Language. So let us have an introduction to UML. We'll see why UML, what are the principles of modeling, why it is called a modeling language, what is UML, the conceptual model of the UML, various building blocks, the rules, common mechanisms. So why this model? Because UML contains word model. Why model? Because we have a problem, right? Now what we want to do is we want to analyze this problem. So we want to model it. Unless we have a model in front of it, we will not be able to analyze it properly. Just to simplify the reality and try to capture the requirements and then visualize the system in its entirety as a whole and then specify the structure and behavior of the system. Then once we have analyzed it, we'll go for the design. That is designing the solution for this problem domain. What we can do is document the solution in terms of its structure or behavior. So the principles of modeling includes, first, you have to choose your model well. The choice of model profoundly impacts the analysis of the problem and the design of the solution. So if you choose your model well, the rest things will be dependent on it and they will be good if model is good. Every model may be expressed at different levels of precision. So the same level can be scaled up or scaled down to different granularities. That is, granularity means modularity, you can say. But modularity is not a good word, but just understand like that. The best models are connected to reality. That means don't hide important details, but try to simplify the model. There is no single model that would suffice or that will be sufficient. Every non-trivial system which is not trivial, that means it has not been built earlier, has different dimensions in the problem and there will be solutions to each of them. So what is UML? UML is Unified Modeling Language. The UML is modeling language, not a methodology or process. Once again, UML is modeling language. It is a modeling language, not a methodology, no methodology or process. So neither a methodology nor a process, it is just a modeling language. It fuses the concept of Booch, object-oriented, and object dissected by three people, We'll be talking about them. And they are Grady Booch, James Rambaugh, and Ivar Jacobson at Rational Software. And this was accepted as this object management, accepted as a standard by the object management group in 1997. So UML is a modeling language for visualizing, first visualizing, then specifying, constructing and documenting the artifacts of software system. So it is a modeling language. As I said, it is not a process. It is not any other thing. It's a modeling language. First to visualize, then to specify and to construct, then document the various artifacts of the software system. Visualizing means, because we know that a picture worth thousands of words. So a graphical notation articulates and unambiguously communicate the overall view of the system, that is the problem domain. That is why UML is for visualization. Then the second one was specification or specifying. So UML provides the means to model precisely and unambiguously, also completely, the system which is in question. Then comes the construction, that is constructing. So we can build the models with UML that have a design dimension to it. So these are language independent. This is very important. Independent. And can be implemented by any programming language. You don't have to be specific about any programming language. Then comes the documenting. So every software project involves a lot of documentation, from say inception phase to deliverables. So documentation, you have to document the requirements, then the design and the test. So UML provides the notation for documenting some of these artifacts. So conceptual model of UML, first is the building blocks. So the conceptual model of UML, in the building block we have things, or you can call as entities, the relationships and the diagrams. So entity relation diagram, then the rules, and then common mechanisms. How? The common mechanisms for specification, for adornments, for common divisions, for extensibility mechanisms. So UML building blocks, as I said, you have things or the entities, you can say, and the relationship among the things or the entities and the diagram. So the things can be structural, behavior, grouping, or annotational. The relationship can be in the type of dependency, the association, the generalization, the realization, and the diagrams can be class diagrams. It can be object diagram. It can be use case diagram. It can be behavior diagram, or say implementation diagram. So structural things, what do we mean when we say structural thing? The noun of UML models. Usually the static part of the system which is in question. So a class, which is an abstraction of set of things in the problem domain that has similar properties or functionality. So this may be a class. For example, this customer can be a class. What about the interface? A collection of operations that specify these services which are rendered by a class or a component. So these are the collection of operations that are going to specify the services rendered by the class or component. The notation would be like this. Then the collaboration. A collection of UML building blocks like classes, interfaces, and relationships that work together to provide some functionality within the system. We call them collaboration. The notation would be like this. Okay. Please observe this dotted round ellipse. Use case, which is an abstraction of set of functions that the system is going to perform. And this use case is realized by the collaboration. Notation is like this, the process order. Then the active class. A class whose instance is an active object. An active object is an object that owns a process or a thread, that is the unit of execution. Notation is like this. See this, the darkness of the rectangle over the event manager. The component. A physical part typically manifests itself as a piece of software. So it's a piece of software of the system, like you have .c file, say dml.parser, dml_parser, that can be a component. Then a node, a physical element that exists at runtime, and it represents up a computational resource like a hardware resource. For example, like this, it can be a node, a physical element. The verbs in UML models, which are behavioral things, usually the dynamic. So we have taken the nouns of UML models that were static. Now we have come to the behavioral things. The dynamic parts of the system which are in question. So interaction. Some behavior constituted by messages exchanged among the objects, and the exchange of messages is with a view to achieving certain purpose. The notation is like this. This is an interaction. Then we can have state machine, a behavior that specifies a sequence of states which an object is going through during its lifetime. So a state is a condition or a situation during the lifetime of an object during which it exhibits certain characteristics or performs some functions. Like this, this can be the notation. This is a state machine. Then we come to the grouping things. The organization part of the UML model, this is an organization part, and it provides a higher level of abstraction, that is granularity. A package, a general purpose element that comprises UML elements like structural, behavior, and even grouping things. So packages are conceptual. These are the conceptual groupings of the system and need not necessarily be implemented, say, as a cohesive software modules. These are the package, say accounts department. Then the annotational things, the explanatory part of the UML models, which is going to add information or meaning to the model elements. That is a graphical notation of attaching constraints or say comments to element of the model. Like this. It can be an annotation, so it can be represented like this. And the relationships. So what relationships are? It articulates the meaning of the link between two things. It can be dependency, a semantic relationship where a change in one thing may cause, say it is an independent thing, may cause a change in the semantic of the other thing. That is a dependent thing. It can be like this. This arrowhead points to the independent thing. Okay. So if an independent thing, it causes a change in semantic of a dependent thing. Then the association, a structural relationship that describes the connection between two things. Like this. This can be notation of association. Then the generalization, a relationship between a general thing called a parent and a superclass, and a more specific kind, that thing which is called as child or subclass, such that the latter can substitute the former. It can be like this. This arrowhead points to the superclass, right? Actually, it is like this. Realization. A semantic relationship between two things, wherein one specifies the behavior to be carried out, and the other would carry out that behavior being specified by the first one. Say a collaboration realizes a use case. So use case specifies the behavior to be carried out, and the collaboration actually implements that behavior. So the notation could be like this: dot 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 and an arrow. So arrowhead, it points to the thing being realized. So the diagrams, the graphical representation of the model, which is represented as a connected graph. We have vertices connected by arcs, that is the things which are connected by relationship. UML includes 9 diagrams, each capturing a different dimension of software system architecture. They are major diagrams: class diagram, object diagram, use case diagram, sequence diagram, collaboration diagram, the state chart diagram, the activity diagram, the component diagram, and the deployment diagram. All for specific purposes. So let us see the class diagram first. We have seen 9 types of diagram. So class diagram is the most common, which is found in object-oriented analysis and design. So it shows a set of classes, the interfaces, the collaboration, and their relationship. It models the static view of the system. Then comes the object diagram, a snapshot of class diagram, which models the instances of things contained in a class diagram. Then comes the use case diagram, which shows a set of use cases. Use case diagram, that is sets of functionality which is performed by the system. So the actors, which are typically people system that interact with the system, that is the problem domain, and their relationship. So it models what the system is expected to do, use case diagram, what the system is expected to do. Then comes the sequence diagram, which is a sequence. So it models the flow of control by time ordering, depicts the interaction between various objects by message passing with a temporal dimension to it. Then comes the collaboration diagram. So it models the interaction between objects without the temporal dimension. So temporal dimension like sequence is not there, merely depicts the message which is being passed between objects. Then the state chart diagram. It shows the different state machines and events that lead to each of these state machines. State chart diagram. So state chart diagram shows the flow of control from one state to another. Then comes the activity diagram. It shows the flow from activity to activity. So an activity is an ongoing non-atomic execution within a state machine. Then comes the component diagram, which shows the physical packaging of software in terms of components and the dependencies between these components. Then the deployment diagram, which shows the configuration of the processing models and runtime and the component that would live on them. Then the dimensions, because it is of software architecture. What can be the dimensions of a software architecture? This is your user view. Implementation, those who do implementation, they will find it like this: implementation view. Some would like to have the structural view, the behavior view, and the environmental view. So this is the dimension of this software architecture. So we can have the use case diagram here, class diagram and object diagram in the structural view. So user view, if you want to show something to the user, you can put in use case diagram. For structural, making a structure. Class and object diagrams are good. Now you want to show the behavior for that sequence, collaboration, state chart, and activity. Sequence, collaboration, state chart, activity, all these diagrams, 4 of these, they show the behavior view. And when it comes to environment, say, let us start with the implementation view. For implementation, you can have a component diagram. For an environmental view, you can have deployment diagrams. So now, what are the rules? We've talked about various diagrams. Now, there are certain rules. So these rules are: specify what a well-found model should look like, first of all. The UML has semantics for the name. It has semantics for scope. It has got semantic rules for visibility, the integrity, the execution. So we have common mechanism, that is the mechanism or element that apply consistently throughout the language, which is the specification or the adornments or the common divisions or the extensibility mechanism. So we can have these stereotypes or a tagged values or a constraint. What about the adornments? We adorn the model, that is, we want to enhance the model, add up to the model. So it adds to the meaning and semantics of the element to which it pertains, adornments. And notes, these are the mechanisms provided by UML for adorning a model. to increase the meaning. So we can have graphical symbol to render constraints or comments. We can have a node that renders only a comment which has no semantic impact on the element. It is a non-name. So it at most adds meaning to it or provide guidelines for implementation. Stereotypes. It is used to create a new building block from existing block. And these new building blocks are domain specific. A particular abstraction is marked as a stereotype, and this stereotype is then used at other places in the model to denote the associated abstraction. This is a stereotype. This is how we write it. So a stereotype is used to create a new building blocks from existing block. Then we have tag values. These tag values are used as the information of the element, not of its instances. So the stereotype help create new building blocks, and tag values, they help create new attributes. And this is commonly used to specify information relevant to code generation, configuration management. This is how it can be represented. These are the tag value. These are used to add the information of the element. Then the constraints. This is used to create rules for the model. That is the rule that impact the semantics of the model and specify condition that must be met. It can apply to any element in the model, attributes of a class or relationship. These are the constraints. So what we have seen today is modeling captures the system in its entirety along with the different dimensions of its complexity. It facilitates quick and efficient analysis and design and helps to communicate the overall system architecture, most importantly, unambiguously. And the principles of modeling lay down that the model must be chosen well. Model should encapsulate different granularities. Model can make simplifying assumptions but not hide the important facts. And no single model can capture all the dimensions of the complexity. And UML is a language that helps analyze and design solutions for software-intensive systems, developed by Booch, Rambaugh, and Jacobson at Rational. And now it is adopted as open standard by OMG Group. So UML is a modeling language for visualizing, for specifying, for constructing, and documenting the artifacts of a software system. It is a modeling language, not a methodology, nor a process. So it is not a methodology, nor a process. The conceptual model of UML comprise the building blocks of UML, its rules and certain common mechanisms that are applicable across the entire language, and the building block comprise of things, relationship, and the diagrams. And the things are again can be grouped into 4 categories. They can be structural thing, they can be behavioral thing, they can be grouping thing, or annotational thing. The structural thing describes the static part of the model and are of 7 types. It can be class, interface, collaboration, use case, active class, component, and node. Behavioral things describe the dynamic part of the model and are of 2 types: interaction, state machine. The packages are included under grouping things and nodes under annotational things, and the relationship links thing to each other, and they can be dependency, association, generalization, and realization. The diagrams are essentially connected graphs. We have set of vertices that are connected by arcs, so object or things or entities by relationship. So there are several types of diagrams, each one capturing different dimensions of the system complexity. So diagrams are of 9 types: class diagram, object diagram, use case diagram, sequence diagram, collaboration diagram, state chart diagram, activity diagram, implementation diagram, and deployment diagram. And the UML has semantic rules for the name of the classifier, the scope of these name, the visibility of these name, and the integrity and the execution of the model. The certain common mechanism which apply uniformly across the model. So we have specifications, common divisions, adornments, and extensibility mechanism. So nodes are the most important adornments or add-ons used that add a meaning to the classifier. The extensibility mechanism includes stereotypes, tag values, and constraints. So these are the references from the content, from where the content has been taken. So thank you so much. This was a basic introduction of UML for you.